G'day and welcome to the office. Today we're going to take a look at the resistor color code chart and how to identify values of resistors by looking at the color code that are on them. So when you look at resistors, they all have a bunch of colored stripes or bands on them. And these bands help us to identify what the value is of the resistor. So how do we go about doing that? Well, you need a decoder chart, I guess, but the resistor color code chart. And each color represents a different value, where black is 0, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, and white 9. And then there's a couple other colors on there as well. Usually there's there's one of two metallic bands, gold or silver. And occasionally you're going to come across resistors with no band at all. Now these metallic bands, or no band whatsoever, tell us what tolerance the resistors will be, where gold will be plus or minus 5% of the stated value, and silver would be plus or minus 10% of the nominal or stated value. So as long as you know these numbers, you can easily figure out what the value is for a given resistor. So let's take a look at a resistor and see if we can figure out what's going on. So here we have a resistor. Now you'll see that there's the tolerance band is way over here. It's the last one of the sequence. So it's always first digit, second digit, the multiplier, and then the tolerance. So this one is orange, orange, brown. So let's write that down. It's orange, orange, brown, gold. And if we look at our table, we can see that orange is actually 3. So for this one, it would be 3 for the first digit, 3 for the second digit, and then brown. There's a couple ways to do this. One I find easier than the other. But you see brown represents 1, and it has a multiplier of 10. So we could take 33 and multiply by 10, and we would then end up with 330. The other way you can do it is, if you remember that brown is 1, just add 1 0 to whatever your value is. And again, it would be orange 3, add 1 0, and you'd end up with 330. Now gold is plus or minus 5%, which would be 10% would be 33 ohms. Half of that would be 33, would be half, be 15, 16 and a half, plus or minus 16 and a half. So that would be plus or minus 16 and a half. So that could be 346, or if we take away that, it would be 314-ish, I guess. So the value should fall within those two limits. So let's take a peek. Let's hook this up to our meter here and take a quick measurement. And the measurement is 327.9. And 327.9 falls well within those two limits. So let's look at another example just to see how it works. Let's choose something different. Here's a very common resistor right here. It's like any form of literacy. Once you get used to it, then it becomes easier and easier. So again, wherever the metallic band is, or the greatest gap, and we'll look one with a big gap here soon, that is the end. So we have to start from the other side. So this one is brown, black, red, plus or minus 5%. So if we look at the chart, brown, well, that's 1. Black is 0. Now red, we either multiply that by 100, which will give us 1,000, or red also represents the number 2. So we could also just as easily add 2 zeros. And that gives us 1K, plus or minus 5%. So this one would be between 1050 ohms, or on the lower limit, 950 ohms. So plus 5% or minus 5%. So let's measure this one and see if it as well falls well within the limits. So it's hooked up, and it's at 1004 ohms, 1.004 k ohms. So sure enough, that falls well within the stated plus or minus 5% for the 1K resistor. So there you go. It's just that easy. Let's find one that's a little differenter, if we can, just to get a different value. Oh, this one's can be a little bit tricky. Again, it's really small, so it's kind of hard to see this one. Let's see, get it to focus. Come on, there you go. This one is brown, black, blue. So we got brown, black, blue. It's blue or violet. It's really, really hard to see if that is focus. Really hard to see if that is blue or violet. So we'll measure it anyways. So according to our chart, brown is 1, black is 0, and blue is 6. 1, 2, 3, 4, 5, 6. Break it up into threes, and that to me looks like 10 meg ohms. All right, that's out of view. 10 million ohms. So let's throw it on the meter. And this would be getting closer to the range that the meter is not going to like. The accuracy is going to go out the window just a little bit, maybe. And sure enough, if you look at it, it's 10 meg ohms. But you can sort of see how the stripes are a little bit off to one side. And the stripe that's the closest to the end, the non-metallic stripe, is where you start your colors. Your first digit, second digit, multiplier, and then your tolerance band. So there you go. I hope that makes it simple enough and straightforward enough. And now you know how to use the resistor color code chart.